Hello and Assalamualaikum. My name is Muhammad Faris bin Kamarudzaman. I am computer engineering student at University Malaysia Perlis. For my final year project, I designed and developed a performance and stamina monitoring system of football players. I am supervised by Dr. Nurul Fazira Binti Azir. First, let's look at the history of football and its monitoring system. The first monitoring system recorded in world of football is during 1950, where Charlie Shrip, a military and an accountant, have created a system that record and analyze the statistics around the player movement on the pitch by manually watch and analyze the football match using pen and paper. The football monitoring system has been evolved since then. Modern day monitoring system use object detection that monitor and analyze the player performance. This system uses multiple cameras that installed across the stadium which will capture the player movement. The reason I want to develop this project is because of some problem faced by the amateur football team nowadays, which is there are no real IoT system that can represent the player's attribute and performance in form of values. And most of the monitoring devices with IoT are mainly developed for big club only, which are not suitable for amateur football club and its player to implement and use such system. The third one is that the difficulty for coaching staff to decide what training dress for their players. So, the objective of this project is to design a system that can represent football attributes in form of numbers and value. This should help the manager and coaching staff to evaluate their players. The next objective is to create a wearable device that can be used by a small football team to monitor their players' performance. The third objective is to design a system that can help coaching staff decide type of dress for their players. The system should be IoT based so that the player's performance and development can be monitored anywhere at any time. According to statistics, only 2% of football matches where the player have to dribble the ball. The other 98% of the times require the player to running, sprinting and backpedaling. So the system are going to evaluate only 3 attributes: player speed, acceleration and stamina, since these 3 attributes are mandatory for every football player. The system also has an extra feature, which is it's able to identify the player's kicking angle when they're taking a penalty kick. For measuring and evaluating the player's speed, since speed is the distance traveled by the player divided by the duration of the interval, the system are using the GPS module to detect the distance traveled by the player and divide that distance with the time taken by the player to reach that destination. Then the speed that are being measured will be compared to the average football speed, which is 7.35 meter per second. The figure shows the working principle for GPS module. For evaluating the player acceleration, the system uses Accelerometer to measure the player's acceleration. The acceleration will be compared to the average football player speed, which is 0.92 meter per second square. The figure shows the working mechanism for accelerometer. To evaluate the player's stamina, the system uses heartbeat sensor to measure the player heartbeat per minute. Then the system will use the following formula to get the player's stamina values. The figure shows the working principle for the heartbeat sensor. For measuring the kicking angle, the system uses Gyroscope to get the foot angle during the penalty kick routine. For each of the kicking angle, the ball travel speed after being kicked by the player will be measured manually. Then, that ball speed are compared to the ideal ball speed, which is 80 meter per hour. The figure shows the working mechanism for Gyroscope. However, for this feature, due to the pandemic COVID-19 and the movement control order, this feature cannot be expanded any further due to the lack of sample space. For hardware specification, the system have 2 microcontrollers, the Arduino MKR1000 WIFI, that are responsible to evaluate the penalty kick technique and upload all collated data to the ThingSpeak, and Arduino Uno Rev3 that are responsible to evaluate the player's attribute and display the player's performance values. The system uses Bluetooth module as a medium for both microcontrollers to communicate with each other. There are 4 sensors and modules for measuring the player's performance: accelerometer sensor, gyroscope, heartbeat sensor, and GPS module. For user interface, there are 3 components: the OLED display, 1x4 keypad, and a buzzer. Meanwhile, for the software specification, we are using Arduino IDE to code both microcontroller and ThingSpeak as a IoT platform. The system prototype have two separate parts, the arm sweatband part and the knee guard part. For the arm sweatband part, there are two layers, the inner layers and the outer layer. For the inner layer, all sensor and module that connected to Arduino Uno Rev3 will be placed. For the outer layer, there will be the UI component. All these components are connected to the Arduino Uno Rev3. While for the knee guard part, there are gyroscope sensor and the Bluetooth module that are connected to Arduino MKR1000 WIFI. Now let's see the project testing and demonstration. This is the demonstration video. I test the system by select the acceleration evaluation mode. The buzzer will start buzzing to indicate the countdown. Now, as we can see on the screen, this is the initial value shown on the ThingSpeak. After I finish the acceleration evaluation, the ThingSpeak should update the acceleration performance graph. This is the performance value for each attribute that being displayed on the OLED display. On the left side is the performance value before the previous acceleration evaluation. And on the right side is the result after the previous acceleration evaluation. We can see the acceleration value have dropped from 71.04 to 69.82 after the evaluation. So, as a conclusion, the project was successfully developed and meeting all the main objectives. However, there are some flaws in the system. The first one is the system is not waterproof. Since the microcontroller and all sensors are implemented directly to the arm sweatband, it is impossible to wash the arm sweatband without breaking the component in it. The other flaws is that the system requires a stable, constant internet connection to update the data to the ThingSpeak. Without a stable network, the data represented in ThingSpeak can be inaccurate. For the future recommendation, the system can be developed into waterproof system with ingress protection rating. The system can also be implemented with more features such as evaluating players' jumping height, strength, and the stamina recovery using various other sensors. That's all from me. Thank you.